Hello everyone, my name is Sreejith. The topic of today's discussion is software obfuscation, and the study is focused on the performance cost of different software obfuscation types on Android applications. A quick look at the agenda. We will start with the main idea or motivation behind the research, go over some definitions, then understand the research objective in relation to the terms and we covered in definitions, framework and research methodology, followed by overall conclusion and results. This is the paper that we have referred. The main motivation and idea is to understand the relation between obfuscation, code complexity, and performance. So you see these interlocked gears representing how these three concepts are interrelated. We all were introduced to code obfuscation in one of our assignments. We understood that it's about making the code really difficult to read, making it difficult for the reverse engineer or the attacker to reverse engineer. Complexity or difficulty is the degree of effort that an attacker would need to understand the code and reverse it. So, in general, with obfuscation, the complexity of the code should increase. These are the types of obfuscation in general, and the highlighted ones are covered in the study. These are the quality metrics, and in this research, the quality metrics are defined at method level and class level, and we see that the quality metrics that is covered is cyclomatic complexity, which is related to the control flow, the dependency degree, denoted as dep degree, relates to the data flow, and object-oriented design matrix, which is more about the class method structure. These are the class level. I will not go in detail about these. Coming back to the research objective. So we saw obfuscation, complexity, and performance. The objective of this research is to study the performance cost of different obfuscation in relation to the complexity matrix that each obfuscation achieves. And then finally, find out the obfuscation methods which are most costly in terms of performance. This is the framework. In this framework, we see how the application is reverse engineered. So we start with the APK file, unpack it into its jar, and in this framework, Pandora is the obfuscation engine, wherein all the different types of obfuscation will be applied onto the unpacked code. Then we see another naming convention here, which denotes the kind of obfuscation that is applied onto the unpacked code. And then finally, a repackaged APK is made. On the side, you see the SSM tool, which is used to compute the new complexity metric. So you see after each obfuscation process, a new complexity is computed using this SSM tool. Androism in this research is used just as a reference for the SSM. How is the performance measured? So it's a kind of before and after measurement. So the CPU cycles for all the methods that are invoked in a typical walkthrough will be measured before, and then post obfuscation, it will be remeasured. For the measurements, the tool that is used is Android Profiler, which is an event-based profiler that captures the time spent on a Java method level. So I'm taking a different approach here. I'm directly sharing the overall conclusion of the study. The overall conclusion says that integer encoding and compose locals obfuscation methods prove to be really good in terms of increasing the complexity of the code, at the same time does not impact the performance. So let's dive in for more details of how this result is being inferred. Let's take a look at the impact of obfuscation on dependency degree and its effect on performance. We see that as the best case, the integer encoding increases the code complexity of dependency degree by 0.55588. At the same time, the performance impact is minimal. The second best case is compose local, and we see that it increases the dependency degree by a good amount and impacts the performance in 0.339. Now, when we compare these two, it appears that it's 5 times impacting the performance negatively. Looking at the worst case scenarios, we see that string encryption does not really impact the complexity. It doesn't really help increasing the complexity of the code, but the performance is 0.558 times increased. The next is move method. In this also, the complexity is not improved much, but the performance is 0.519. Coming to LOC, which is the line of code, again, the integer encoding and compose local have a good impact and improvement in the code complexity and not having a bad performance impact. If we look at the worst case, we again see that string encryption is not really helping to improve the complexity, and the performance impact is really high. Looking at cyclomatic complexity, we see that encapsulation of field improves it a bit in comparison to the others. Only encapsulation of field gets improved by 0.2, and the performance impact is not much. So anybody interested to really understand how this paper is organized, I've just put down few notes how the researcher, the authors have explained the concepts. When I thought about the future work or the kind of weakness, I felt as a developer, I should have got to know the kind of obfuscation that fits in really well for different types of applications like games, banking. Depending on the type of application, the architecture of the app would be different. The code patterns would be different. So it is important for a developer to understand which kind of obfuscation will not have a negative impact on the performance, which should be related to the app the developer is working on. This is another related research that I found out. This talks about different obfuscation methods and how it really affects the code complexity. This is a related research. All right, let me know if there are any queries. Thank you.